All right, hi everyone. So in this video, we will see how to find out the distance between two complex numbers. So we have two complex numbers, Z and W. All right, and we are interested in finding out what will be the distance between these two. So first thing what we'll do is we will plot these two complex numbers on a complex plane. Okay, so let me change the background. Okay, so let's say this is the imaginary axis and this is the real axis. Okay, so let's plot these two complex numbers. 2 plus 3i, so 1, 2. Real part is 2 and imaginary part. So first I'm plotting z, and for z the imaginary part is 3. So 1, 2, 3. So this is the complex number z. And then for w, real part is -5. So 1, 2, 3, 4, 5. And imaginary part is -1. So that's here. So this complex number W is this one. So this is W. And we want to find out what is the distance between W and Z. So first, I'm going to connect these two complex numbers with a line segment. And we are interested in finding out what will be the length of this line segment. So I don't know if you have heard of the distance formula, but if you've heard of it, then it's well and good. In geometry, we have done the distance formula, which is nothing but the application of Pythagorean theorem. So what I will do is I'm going to apply the Pythagorean theorem here. What we'll do is we will complete this triangle. Okay. So this is, if we see this is a right triangle and we are interested in finding out this distance. Let's say this distance is D. Yeah, we want to find out this distance. Now, as per Pythagorean theorem, in this right triangle, this D length, D is nothing but the length of the hypotenuse of this triangle, right? And we know that as per the Pythagorean theorem, the length of the hypotenuse is given by square root of the sum of the squares of the lengths of the other two sides. So let's say that, let's say this length is x. This whole length is x. And let's say that this whole length is y. Okay, so so basically D will be square root of x squared plus y squared. What is the value of x? So over here we are 2 units, right? This is 1, 2. And over here we are 5 units away. So this entire thing is 7. So this becomes 7 squared. And the length of y is, so above the real axis, I am 3 units up. And below the real axis, I'm 1 unit down. So this entire length is 4. So 7 square plus 4 square. Now I'm going to remove this background. So we get 7 squared is 49. 4 squared is 16. So we get 9, 6 is 15. 1 carry over 4, 5, 6 square root of 65. So this distance is square root of 65. So this is how we find out distance between two complex numbers. And the second concept is we want to find out which complex number is exactly in the middle of this line segment over here, exactly in the middle. Okay, so we find that out by using midpoint formula. Okay, so let's move to the next page. First, I'm going to write down the midpoint formula. So let's say we have one complex number Z1 given by A1 plus B1 times iota. And we have second complex number Z2 given by A2 plus B2 times iota. Okay. Now, if you plot these two complex numbers in the complex plane, so this transforms to the point A1, comma B1, and this will become A2, comma B2, right? And you just plot these points on the complex plane. Now, if this, let's say this is Z1 and this is Z2, and this is a line segment joining these two complex numbers, and we want to find out a point which is exactly in the middle of this line segment. So there is something called midpoint formula. You might have done it in your geometry module. Midpoint formula is given by, now if this point has coordinates A1, comma B1, and this point has coordinates A2, comma B2, so the coordinates of this point, let's say this is X, comma Y. So these coordinates are given by, your X will be given by A1 plus A2 divided by 2, and your Y will be given by B1 plus B2 divided by 2. Okay. So the complex number which will be exactly between Z1 and Z2 will be, let's say it is Z3. In terms of Z1 and Z2, it will be given by like this. A1 plus A2 by 2 plus B1 plus B2 by 2 times I. Okay, so let's apply this rule and find out the distance between these two complex numbers. Okay, I'm going to write down this formula over here. So Z3 is going to be A1 plus A2 by 2 plus B1 plus B2 by 2 times I. All right, so A1 is 2 plus -5 over 2 plus B1 is 3 plus B2 is -1 by 2 times I. So 2 plus -5, that means 2 minus 5 is -3 over 2 plus 3 plus -1, yani 3 minus 1, that is 2 over 2 times I. This is -3 over 2. 2 over 2 is 1. So this is the complex number, which is going to be exactly over here. And this is going to be -1.5. Yeah, it kind of looks like -1.5, the x coordinate, and the y coordinate is 1. Okay, so this point is a complex number, -3 by 2 plus I.